Dr. Peter.
So the discussion, I think, early this morning was about the history of AI and those pioneer persons that started it, especially Geoffrey Hinton. And then there was a good insight that was provided by Mel on the techniques and approach being used by machine learning. It's either supervised or unsupervised learning. But later on, you will also see another technique being used in ORAN, which we'll discuss later. And then, of course, the last speaker, Dr. Peter C., he discussed about fairness and trust and transparency, accountability, and social benefit, and especially privacy and security, which are really the corner or pillar stones of AI ethics. So before I go to the real topic for today, which is the application of AI in Open RAN architecture, I would like to also touch base on some of the industry that AI is being used now in the Philippines. And one of them, which is really close to my heart, is the call center or BPO operations in the country, right? As you can see, this is the most fastest growing industry in the Philippines. For this year alone, in 2023, the estimated revenue from this business is 30 billion US dollars. And that's not, the complete year cycle yet, right? This is how big the call center operation in the Philippines is now. We are among the top capital center in the world, capital call center in the world, and we are at par with the best. So as you can see, most of the AI applications are being centered also in this towards this industry. So how does the BPO space uses AI? So I think the last annual report, I think the performance of the call center in the Philippines, I think it had a 13 or 14% performance improvement in the overall operation. And the driving force behind it is, of course, automation, right? Automating our processes in the call center. And it is being driven by AI. So it is not alone because of the quality of the agents that we hire or the training that we provide, but it is because of AI, which is the one driving the automation in the processes that we do in our BPO. So as you can see, the first topic there is streamlining call center processes. So AI is now involved in compiling answers to most of the frequently asked questions from the customers, right? So that when you encounter the same customers, you already know the history and you can answer him directly right away without sometimes asking the customer about it. So there's also deeper insight into analytics because of AI. Consumer trends, their buying habits, their needs are being monitored using AI algorithms. And the most important one is boosting call center agent productivity, right? Now our agents are equipped with the tools like AI chatbots, right? So now they're not the one answering your chat. The AI application is the one answering them so that the agents can really concentrate on answering their calls and not doing their chatting. It's already being automated. And then this is one of the metrics that's really important, first call resolution rates, right? When a customer calls, it is important that you resolve his issues, right? And now AI is also being used to identify roadblocks that can hamper resolution of their calls. So there are analytics behind it. Then maybe they are prioritizing the calls which should be resolved first. And that is a really good application of AI in improving the productivity of our call centers. And because of the first call resolution issues that are being resolved quickly, of course, the average handling time of the agents are being lessened, right? Before, the average handling time is 6 minutes. Now, I think it's already half, 3 to 4 minutes, because our agents are so efficient because of their tools. Now they're able to take in more calls because they are able to service a customer in a lesser period. So the bottom line for our call center is to enhance customer experiences. And AI is now being used to better understand the customer behavior and their needs. So this is how AI is being used in our BPO industry. But to be more specific, just to give you an example on how the natural language processing or one of the higher machine learning languages that we use, the call center operations normally use speech analytics. So there are three basic types of voice interaction. We have voice recognition, we have natural language comprehension, and we also have voice synthesis. So now, how do you use this AI to analyze all voices that are coming into the system? As you know, our call centers have a very good platform for recording for our conversation, right? And because of AI, they are now able to pinpoint a unique voice signature for each of their customers. So having said that, once you are on a phone with your call center agent, sometimes the minute you speak, they will already pull up your account. You don't need to mention any bank records or credit card numbers, right? So in order to understand this better, maybe I can show you an animated video for a while. I'll stop sharing.
These are your even before they contact you, they already know almost everything about you and your competitors' offers. They demand and expect more than ever before, leaving you a small window of opportunity to meet their needs. This is the decisive moment of customer service, the exact moment to increase your customer satisfaction and loyalty, and to leverage the business opportunity. For example, Mike calls his bank.
Fairbank Financial, this is David. How can I help you?
Hi, David. I received an email from the bank asking me to confirm my account details. I didn't respond because I thought it was spam, but now I'm concerned that my account details may be incorrect.
With the help of NICE Interaction Analytics, Fairbank identified a new phishing attack targeting its customers. A real-time rule was quickly set up to identify affected customers and guide agents on how to assist them.
Mike, this email is part of a phishing attack. Fairbank will never ask you to confirm account details in an email, okay? So please delete the email immediately and make sure your antivirus software is updated.
NICE Real-Time Speech Analytics provides you the tools you need to shape the interaction in real time. It then triggers agent guidance, suggesting the next best action to optimize call handle time, improve customer experience, and maximize sales opportunities. Now you own the decisive moment. NICE.
So with that video, what stands unique in that video? Did you hear the customer say something about his bank account or maybe his bank account number? I don't think so, right? So the agent already knows because of his unique voice signature, the agent was able already to pull up his account, right? And know what's happening, even in his emails, right? That there's a phishing email that's going around behind his back. So this is how, AI is able to tap into our processes and use it to improve the services in our call center. Now, another part of our experience with AI is using our mobile phone, right? So right now, whether you like it or not, AI is here to stay in our mobile phones. As you can see from the graph, smartphones using AI is constantly increasing, right? So there's no stopping it anymore. And this is just the data since 2017. So if this is a 35% growth, more smartphones coming out of the manufacturing line are now using AI in the phones that they manufacture. So what does AI look like in our mobile phones? So we have Siri in our IP phones, right? It's a voice assistant. So that's AI. AI is also in our camera to recognize our voice and maybe use it for security. When we use our searches for images, right? It's already in our phone. So AI is also behind that. It is also a contributor to augmented reality. For example, like Apple's Animoji. In our day-to-day operations, like the Google search or behind the Google search engine, every time you search from your phone, it is being adapted to work behind the scenes in applications as battery life management. So AI is also behind that. And also for security, again, facial recognition. In order for us to open our applications in our phone, if somebody uses your phone and he's not authorized, if he's not the correct face, he cannot open your phone, right? So this is how AI looks like on our mobile phones. So whether you like it or not, AI is now here to stay. So algorithms are capable of recognizing our own face, even they wear or take off glasses, or even grow facial hair. That's how powerful the AI algorithms now are in the AI algorithm that's embedded in our phones. So the unique question is, how do AI apply to our wireless mobile network, right? So the discussion, I think, evolved, which was presented by the earlier speaker, was on machine learning and artificial intelligence algorithms. And you have models wherein you could improve the efficiency of your programs in order to better utilize the environment. In this case, the wireless network environment. So what are the normal problems that we have, or the wireless operator in the Philippines are having problems with? Normally, they have problems with forecasting peak traffic and resource utilization, especially in applications. There's also a big problem on optimizing and fine-tuning the network parameters for capacity expansion. And then this is a perennial problem. Most RF engineers knows about it. So how to eliminate coverage loopholes, right? By measuring the interference and using the intersite distance information. So again, to better understand, before I discuss the other slides going forward, maybe we can take a look at another video, how AI is now being used in the US for the rollout of Open RAN infrastructure.
Hi everyone, and welcome back to our channel. I'm Brian Walls, Product Marketing Manager here at Parallel Wireless. In today's video, I'll share some advances we're seeing in artificial intelligence and machine learning. Advances that can help mobile operators optimize and automate their network operations, while making these networks more predictable and less costly to manage. First, let's set the stage. There's no doubt that mobile network operators are facing strong pressures to involve their businesses and their operations to support profitable growth and differentiation. Explosive demand for bandwidth persists while ARPU pressures mount due to competition and limited service innovation. And yet users continue to demand more performance while ARPUs remain flat and declining in some cases. Meanwhile, operators are seeing rising CapEx and OpEx associated with the move to newer technologies such as 5G, which then brings ever-rising end-user expectations. And with these challenges and demands of mobile networks come ever-increasing OpEx costs and complexity. Additionally, supporting multiple access networks for 2G, 3G, 4G, and now 5G requires ever more RAN capacity and denser networks. The 4G radio access network is roughly 10 times denser than the 3G network, and that densification is predicted to continue. 5G networks are predicted to be as much as 10 times denser than 4G networks, which will make them 100 times denser than 3G networks. As mobile networks are growing more complex and more costly to operate, the self-optimizing capabilities found in an Open RAN solution will be essential to efficiently manage them. And this self-optimization capability comes from a number of areas. Automation of network tasks can simplify management and operation while helping operators execute at scale without dramatically increasing support staff. Secondly, the O-RAN compliant architecture inherently incorporates intelligent frameworks for machine learning, specifically the RAN Intelligent Controller, also known as the RIC. The RIC enables programming control of the RAN at both a near real-time and non-real-time level. The next area of self-optimization comes from RIC applications such as RApps and XApps. These enable automatic execution of data-driven decision-making and machine language models. These XApp and RApps enable the network to use the right level of automation and intelligent controls depending on the complexity of the operation. And lastly, the wealth of network data analytics that will be captured in an Open RAN environment can be processed by predictive AI ML models. These models can be trained and retrained for predictive, intelligent operation. This will be a huge advancement for our industry by leveraging automation to the fullest extent and eliminating the element of human error. Let's discuss this area of AI and machine learning in more detail. Machine learning is a subdiscipline of artificial intelligence that can be used to bring new capabilities to mobile networks. It can be used for a number of things, including predicting and forecasting parameters in the future, recognizing occurrence of patterns from large logs, detecting anomalies in measured values, predicting possibilities of failure future, and classifying objects in real time. And with these machine learning predictions and classifications, operators can deploy intelligent applications that improve the operation of the network. Some of the benefits operators include avoiding catastrophic failure of devices, improving customer experiences, and essentially provisioning resources at the right place and the right time based on data-driven decision-making. In many cases, using advanced machine learning-based forecasting and decisions to manage the network eliminates the human element from simple operational decision-making. It brings in expert-level operational efficiencies to the network. The Parallel Wireless Cloud-Native All-G Open RAN architecture shown here contains many of the network elements that are instrumental in building in these AI ML capabilities that we've been discussing. Our solution is software upgradable and thus reduces the cost and complexity of transitioning networks to 5G. Parallel Wireless provides a variety of solution options spanning the complete end-to-end ecosystem, such as RU options with multiple radio hardware vendors that can interconnect with the Parallel Wireless DU and CU within the Open RAN ecosystem. The old in the diagram shows within the ORAN architecture where the RAN intelligent control framework lies. This RIC framework enables mobile operators to use AI, ML, policies, and enrichment information to execute the RAN intent or the business objectives towards the RAN while automating and optimizing RAN operations at scale. Let's look at how an Open RAN solution with a built-in AI ML framework and a RAN intelligent controller integrates AI ML-based decision making. ML models are trained based on data received from different network functions for analysis. The ML model training facility is composed of parallel wireless software, data and control flows, and data science learning algorithms. It's essentially the engine through which the customer data is fed. These models are then used for inferencing and acting on other RAN nodes to fine-tune the network, providing the best end-user experience. ML inferenced actions can be manifested in RApps and XApps, as well as in the CU or the DU, or even in the EMS, wherever it makes most sense to solve the mobile operator's network issue. An ML model is a knowledge base. It only knows how to solve a problem through training with data. Once it's trained, it creates a model to do the inferencing, forecasting, etc. The goal is to use these predictions for network planning, for power savings, and other network actions that will bring benefits to the mobile operator in self-optimizing the network. Let's take a look at how AI and machine learning models can be put into place to enable mobile operators to better manage network resources. In this example, let's look at dynamic traffic control. In the scenario we're looking at here, we see a variety of urban areas, including a stadium, a business district, and a transportation hub. We see coverage cells providing mobile network services for these areas, along with additional capacity cells that are intermittently brought online when demand increases beyond the capability of the coverage cells. Presently, for mobile network traffic planning, most operators use long-term trend analysis as a basis to program the schedulers that turn on and off the capacity cells at predetermined intervals. But you can't schedule many unpredictable events such as weather, pandemic impacts, and other variables that impact the demands of the mobile network. Trend analysis-based traffic optimization technique is static. It requires constant manual tuning to deal with cyclical traffic pattern changes. And to operate within safe limits, operators maintain higher capacity buffers to respond to micro-level traffic demands to maintain quality of service. To meet dynamic traffic peaks, operators over-provision capacity, throughput, and coverage in these areas, which adds to higher operating costs to the bottom line. In the future, for dynamic traffic management, machine learning models in the RAN architecture will continually forecast network traffic for a zone based on predictions. Forecasting accuracy will enable better operational efficiencies and reduction in costs. Here's that same scenario in the morning between the hours of 7 and 10 a.m. We see lots of mobile users arriving in the commuter rail station, driving into the city center, and walking into their offices in the business center. The graph here represents the ML modeling of the transport hub and business district areas. The line graph shows both the ML predicted capacity needed in the red line, which runs ahead in time, of the blue line, which shows the actual capacity needed by the devices on the network. This example shows a very accurate model able to efficiently manage when capacity cells are needed to be brought online, as the predicted demand exceeds the capability of the coverage cells. Now we see the same scenario, but in the middle of the day, between the hours of 11 a.m. and 2 p.m. We see people moving around the business district, nearby shops and restaurants. There's less vehicle traffic and only a little activity near the transport hub. Again, the red line on the graph shows predicted capacity needs versus the blue line, which is showing the actual capacity needed in the business district. And again, we see an accurate ML forecasting model in action. which would enable better operational efficiency and a reduction in costs for the operator in turning on capacity cells. This fully automated, intelligent network operation enables better management of resources. The two graphs here show how the predictive machine learning model can even factor in the effects of forecasted weather on the predicted capacity demands of the network. Here, under poor weather conditions, the model is also forecasting for fewer mobile users and devices, as well as a later start in the time for the demands on the network. Now in our demonstration scenario, it's early evening. Users and activity shift to the stadium because there's a game playing tonight. But the transport hub and the business district are quiet, thus the capacity cells in those areas are turned off. The line graph again shows predicted capacity required versus the actual traffic in the stadium area. Again, the ML model helps mobile operators continually forecast network traffic for a geographical area and then adjust capacity for demand. This was an example of how machine learning models can improve accuracy of traffic forecasting and thus enable better operational efficiency and reduction in operating costs for the mobile operator. Let's summarize. Parallel Wireless's open, innovative, software-based Open RAN solution puts mobile operators in the driver's seat for network design and evolution. With a more intelligent and self-optimizing Open RAN network, mobile operators will be able to lower the cost of operating their networks, better manage the complexity, and begin to exploit these emerging AI ML concepts. With Parallel Wireless's Open RAN solution, mobile operators can expect these business benefits: deployment cost reduction. The disaggregation of hardware and software allows abundance of capacity at much lower cost. Non-proprietary interfaces for LG give operators the ability to select any vendor for hardware, including radio units and COTS service. And agility through software delivers network deployments up to 50% faster than traditional RAN. Other benefits come from Open RAN being an out-of-the-box solution. Cloud nativeness brings elastic scalability across all components. RAN functions are deployed as microservices and containers, bringing agility with no capacity or coverage limits. Intelligent optimization in real time comes through ZTP, CI/CD, and AI and ML. And all of these benefits help operators meet the 5G economic requirements of increased network density. Lastly, Open RAN brings new business opportunities. By bringing 4G and 5G capabilities such as low latency, network slicing, RAN sharing, MNOs can provide differentiated services resulting in new revenue opportunities and a faster return on investment. That's all for today's video. I hope it was helpful. If you like
Okay, I hope you learned something from that video, right? So as you can see, in the O-RAN environment, most of our CUs and CUs and DUs are already virtualized machines, and we are using the cloud, right? So most of those things can be leveraged by using machine learning and AI to tweak and optimize the whole infrastructure, right? So now the concentration is to have application-based traffic steering and aggregation across the network. We also have the capability of dynamic network slicing, and we can now offer machine learning and AI as a service offering to our end users, right? So as you can see, this is the whole picture of how AI and machine learning will be integrated to our future Open RAN wireless network. So machine learning is the one that produces the algorithm that collects and analyzes the data. It provides the knowledge, and the decision making is done by the artificial intelligence algorithm so that they can fine tune the network depending on the traffic being generated by the users, which is on the left. All the things that are connected to the network. So I think the earlier speaker mentioned that because of machine learning and the techniques used in machine learning, we can have algorithms which can produce supervised learning and supervised learning, right? And this was mentioned before, that these are the two major approaches being used for some applications in the industry. But in ORAN, these two are also being combined to also have a reinforcement learning. So reinforcement learning is a combination of both supervised and unsupervised learning, so that you can have a more powerful machine learning approach, because the data that's being collected in the mobile network or wireless network are so diverse and so unpredictable. So we have to introduce another technique, which is reinforcement learning, so that the system can really decide on its own. And as you can see, the normal architecture of the Open RAN system is shown at the right. And all of our components in this architecture normally have inputs and output, right? All of them, which are connected in this one, even those devices connected or are hosted in the cloud. Everyone has an input and output. And in order to optimize them, machine learning is being used to monitor the inputs, and these inputs are being monitored in order to have a good data and being analyzed by the algorithm, so that the AI algorithm can do a good decision making on how to tweak our outputs in the overall Open RAN architecture that's shown on the right. So the typical application, for example, in an ORAN system for ML and AI is in the finding the best beam in our cellular sites based on the density of our users. So with the help of ML and AI, the parameters mentioned below are being monitored, and accordingly, the best beam or the best propagation towards that cellular site is being allocated. And because everything is virtualized, even power can be optimized depending on the traffic of the users in that area. As you can see in the video before, in the morning, the cellular sites that are in the bus stations or in the train stations are the ones being used heavily, right? Because everybody goes to the transport area in order to go to their places of work. But after they are in the offices, the cellular sites in the metropolis area are the ones being heavily used. So the system can be tweaked that all resources that are, underutilized can be used to that cell site which is having a heavy traffic. The next application of AI and machine learning in our Open RAN architecture is through network slicing, right? So because of network slicing, most of our virtualized machines can be optimized with the use of the machine learning algorithm and AI algorithm, so that, for example, a CPU can be allocated, which is hosted in the cloud for a given cell site which really needs it. And those cell sites or equipment that are not heavily being used will have fewer allocation of CPU power. So in the video, the network slicing is mentioned as a self-optimization network. So in a traditional wireless network, every capacity is fixed, right? So you cannot tweak it. But in an MI and AI initiated Open RAN scenario, all of your resources can be optimized according to the traffic that is being generated by your users. And of course, because of this, user quality of service is being improved, network performance is improved, and you can also capture event and logs if there are failures in the system. Other uses of ML and AI in the mobile networks is in the planning and maintenance. In the video, you can see that there is predictive and forecasting that's being utilized by the system depending on the traffic that is being generated across the whole network. So you can also check for network outages, equipment failure, and performance degradation with the use of ML and AI algorithms. And then you can actually modify and dynamically adjust network resources according to the usage of the subscribers, and your capacity requirements are automatically adjusted. Likewise, because of the power of AI, the user equipment mobility can also have an history, right? You can have a time of day of usage, right? As you can see in the video. And this will all be captured by your O-RAN network. And this can be a pattern in which you can monitor and do maintenance to your equipment. And then lastly, AI is also being used to enhance security in our 5G networks so that attacks and frauds can be easily recognized. And patterns can be tagged for certain events to prevent similar attacks in the future. So in summary, wireless operators can deploy AI in 3 ways. It can be employed in our embedded systems using machine learning and AI algorithms. So these are the hardware mentioned by Mel Alipio before, which has limited capacities, right? And then it can also be used in our lightweight engines or the network edge. And then lastly, machine learning and AI platforms can be built within the system to centralize deployment and perform heavy computation for storage of historical analysis and projections, especially to monitor behavior of our cellular sites during certain period of day and time. And last but not the least, the potential of machine learning to be applied to the whole mobile network architecture is limitless, right? From end user equipment, as you can see here, from our radio unit up to the cloud network, AI and machine learning could be deployed in order to make the machine or the whole architecture efficient. Now the deployment of AI in our mobile networks is still in its infancy stage. So there is a lot of, other technologies that can be used, and machine learning and AI is just one of them. So in the near future, every segment or every sector of the whole Open RAN architecture will be touched by machine learning and AI. And this will really be beneficial to the whole system, and hopefully it will produce a better quality of end user experience to the whole network, and of course to our use of our mobile networks. So my presentation is short. I just captured all the basics, and hopefully this is a good exercise for you to really appreciate where we could apply artificial intelligence and machine learning in our environment. Thank you.
Thank you, Sir Noel. Thank you so much for that wealthy insights on the AI implications on Open RAN. Okay, so let's move on to our question and answer. But while we are doing the question and answer, all the participants can now start to find the evaluation and attendance form. So you can start filling it out while we are answering some questions for Sir Noel. Sir Noel, there's a question from Roy Prado. One question is, how is the progress of AI in manufacturing or BPO?
In BPO, as I've said, it's being heavily used in the voice call center, right? Space. One of them is speech analytics, right? For other applications, we have what we call back office applications, right? So AI is also being used in those areas. For example, collecting data from voluminous documents. Normally, those documents, sometimes application forms, sometimes are not being filled electronically. Sometimes they're just being scanned, right? So in that area, AI is also being used to capture the images of those forms and later on identify the customers right away based on those scan forms.
Okay. Next question, Sir Noel, from August Kimson. Hi, Sir Noel. What will be the possible impact of AI development on our workforce in the coming years? Will AI contribute on the downsize of manpower? Thank you.
Actually, that's a good question. Actually, it will not only affect you. It will make my maybe my job obsolete in the future, right? Especially in the areas of planning. If AI is that good enough, they could design the network on their own, right? They don't need network engineers for that task alone. So it's really something that so it is something that we really need to look at, making some of our jobs obsolete.
Okay.